The fundamental counting rule is also called the multiplication of choices. In a sequence of n events in which the first one has k1, so this is supposed to be a subscript, so k possibilities, k sub 1 being the first number of possibilities, and the second event has k sub 2, and the third event k sub 3, and so forth. The total number of possibilities of the sequence will be k1 times k2 times k3 times, and so on and so forth, times k sub n, however many times we do this. So in our first example that we were just talking about, if I have 5 markers, two remotes, and two, we'll just say, other items, how many ways could I select one of each? It would be 5 times 2 times 2, okay? Because I want one of these, and, you're hearing that word and again, one of these, and one of these, and means? And means? Multiply, right, multiply, the multiplication of choices. All right, so starting off with a very simple situation, pretend you have a paint manufacturer. They're manufacturing several different kinds of paints. You can choose one of these 7 colors. You can choose whether you want latex or oil-based. Okay, latex is water-based. It rubs off with water. I used to paint in college, paint houses for a summer. Oil-based. You have to use like mineral spirits to get it off, okay? You can choose what kind of finish you want on it. So do you want it to just be a flat finish, semi-gloss or high gloss? You can choose if you want an indoor paint or outdoor paint. Now, if you've ever painted anything, there's way more choices than this, but let's just pretend these are all your choices. So you're trying to figure out what you're going to buy. You could buy red latex flat outdoor, red latex flat indoor, red latex semi-gloss outdoor, red latex semi-gloss indoor set. I mean, this could be a huge tree diagram if I was going to try to count them all, right? So rather than doing that, I understand that I just multiply these and there's actually 84 different kinds of paint. Okay? So 7 colors times number of types times number of textures times number of uses. Okay? So there was 7 here, 2 here, 4 here, 2 here. I just multiply those. There's 84 different kinds of paint if I'm selecting one of each. Now, there's an interesting button that you've maybe come across on your calculator, and it looks like an exclamation point. Okay, some students that actually play with their calculator, they find that. It's usually on a scientific calculator under the probability button, and it's on your calculator too under the probability menu. I got to show you where that is. Okay, now what a factorial does. Hey, quick question, raise of hands. Who's ever done a factorial? Has anybody ever done this 5 factorial? Who knows what that is? Ooh, Starmont kids, yes. West Central? I can't see you yet. Hang on. Yes. Hey, they all know. Okay, Owen? No. Negative. All right. So, we're all going to learn what a factorial is quickly and where it is on our calculator. Okay? What a factorial does, if I'm going to do 5 factorial, is it quickly on our calculator, it does 5 times 4 times 3 times 2 times 1. Being that we just talked about dependent probabilities, can you see how that might be helpful? When each time if you don't replace something, it goes down by 1, right? So sometimes we want to do this repeated multiplication that's going down by 1. And so this would be 5 factorial. Your calculator will do this without you having to type it all in. With me doing some mental math here, 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. This should be 120. On my calculator, everybody needs to know where it is on this calculator. Okay? It should be under your math button. And then go all the way to the right where it says PRB, probability. And you'll see number 4 has an exclamation point, right? So if you want 5 factorial, you're going to have to type in a 5, go to math, go all the way to the right, and go down to number 4. That's 5 factorial. It should be 120. Okay? So basic understanding of what the exclamation point does. Now an interesting one is always 0 factorial. Most students think 0 factorial is 0. However, it's not. Okay? And I can prove that to you, but I want you to think of one other weird one that you guys know of. Anything to the 0 power is always 1. when most students think anything to the 0 power is 0. Some of you who have been in advanced math realize that anything to the 0 power is actually 1, because that's the only way it will follow the pattern. Same thing with factorial. 0 factorial is actually 1. Because if I have 0 items, the number of ways I could arrange that is just one way, and that's by not arranging them at all. So 0 factorial is 1. All right? So I want you to try that quick. 0 math, just double check it. If you ever have 0 factorial, that just counts as 1. So anything times 0 factorial is just timesing by 1, it would be itself. So that is 1. Kind of an interesting side note. Star it. If you're not sure on a quiz, type it in and see what you get. Okay? Okay, so permutation. We're going to talk about the difference between permutations and combinations. You may have heard these before, but again, I'm hoping we have some clarity with this. But they're ways of counting objects. We're talking about counting rules, okay? Notice the title on this lesson is counting rules. So ways that we can count things. A permutation is an arrangement of objects in a specific order, and I highlighted this order matters. So if you're going to write something in your notes, what you need to write down is this word permutation, and then the word order matters. The order matters. It's how you're counting things when the order matters. Now, this is the long way of doing it. Before you keep writing, you do not have to copy down this formula, okay? This is the long way. You have to do n factorial divided by n minus r factorial, and I have to tell you what all the n and r means, okay? Now, the easier way of understanding this is to understand where this button is on your calculator, letting it do it, and also letting me just explain to you mathematically how it's doing this. This formula I don't care for too much. That shows up, but you're never going to remember that formula anyway. So it's better that you just understand how to do it, okay? So the P button on our calculator does stand for permutation, okay? And it will be best once I do an example, but let's just find the P button real quick. So again, under math, okay? And how I like to do it is I first type in the number that I need. So if I have 10 things, and I'm only arranging 5 of them, I would do 10, and then go to math, go over to probability, go down to this one, number 2, NPR. It's kind of hard to see. Okay, hit enter, and then 5. Now, if you have a fancier calculator than mine, when you push that button, it'll like actually fill it into the little box there. So it actually looks like 10P5, okay? That's 10 items. I only want to know how many ways I could put 5 in an order, and that's how many ways I could do it. It's crazy, okay? It's a crazy big number. But it's following a formula, and it's using factorial, and it's counting up numbers of ways. If you think about it, if I have 10 items, look at my 10 fingers, and I want to just choose 5, and then I also want to arrange them in an order, there's a lot of ways to do that. You know, I mean, I can start with just choosing these first 5, but then think of all the ways that I could arrange these 5 things. Okay? And then I could do my first 4 fingers in this one, and then think of all the different ways I could arrange those. And then I could do my first 4 in this one, and all the ways I could arrange those. And then I could, you know, keep going. There's, I mean, a billion ways you could take 10 items, only choose 5 of them. First of all, there's a lot of ways to choose the 5, and then a lot of ways to arrange them. Okay, so that's that number. That's 10, and we're counting up how many ways we could order just 5 of them. Okay, side. We're also going to learn about how to do a combination. So that's the C button on your calculator. Again, I would not write down this formula or this. I would just notice that when you write down the word combination, make sure you know where the C button is. And what should we write down in our notes? Okay, for permutation, you wrote down order matters. Read this. What should we write down for combination?
Order does not matter.
Order does not matter. Okay, thank you. I thought maybe I lost all of you off the deep end. Okay. Order does not matter. We don't care about their order. Okay. Skip this slide. We're going to go on to this one. Okay, listen closely. Let's read this problem and see if we can figure out whether we should be doing a permutation or combination, and I'm going to show you how to do it by hand. Okay? Suppose a business owner wishes to rank only the top 3 of 5 locations. Okay? So here is also, if I'm thinking about it in terms of my team, which a lot of you are on sports, you have your 5 starters and you want to rank the top 3. How many ways could you do that? Well, there's a lot of ways, okay? You could take these 3, you could take these 3, you could take these 3, and then once you get the 3, it doesn't necessarily mean that this is first, second, third. They might be rearranged different ways, okay? So how many ways could we do that? It's actually 60 ways, but why? Okay, so let me explain this to you and then show you how your calculator can do this for you. When you choose the first person, the person to be in first, you're putting them in an order, okay? We're picking one person out of this group of 5. How many choices do I have? 5, okay? I choose this to be my first person. After I choose that people, how many people do I have to choose for second place? Only 4. And after I choose that guy, I only have 3 left to choose from, right? So it makes sense that I would do 5 times 4 times 3. Now let's think about it in terms of our calculator, okay? So I have 3 spots, and I did 5 times 4 times 3. First place, second place, third place, okay? If I use my calculator, when you're doing a permutation, the bigger number always goes first. How many people am I choosing from? 5. And how many do I want to actually put in an order? Only the top 3. 5p3. And if you type that in on your calculator, it will give you the same thing as 5 times 4 times 3, which will be 60. Okay? 5p3. Why do we know this one is a permutation and not a combination? Because combinations are going to be calculated totally differently. Because you're ranking them, and rank means you're putting them in an order. Whenever you see the word rank, rank means order. Order matters. If order matters, use the P button. Here's a quick way to remember that. O and P are right next to each other in the alphabet. So when the order matters, use the P button. If the order doesn't matter, use the C button. Okay? O and P are right next to each other in the alphabet. Say that one more time. If order matters, you use the P, permutation. Okay, so let's look at this next one. A radio talk show host can select 3 of 6 special guests for her program. The order of the appearance of the guests is important to her. How many different ways can she do this? So just like the last one, it's going to be, we have 6 people. We're ordering how many of them? 3. Try 6p3 on your calculator. See what it gives you. Should be 120. Let's think about that written out, okay? We have 3 that we're selecting, so we put out 3 spots. She has 6 guests. To pick her first spot, how many guests does she have to choose from? 6. Once she puts that guest in that spot, she only has 5 guests left for the second spot and 4 guests left for the third spot. Some of you like mental math. 6 times 5 times 4 is what? 120. This is also 120. Okay? Okay, next one. A school musical director can select 2 musical plays to present next year. One will be presented in the fall and one in the spring. She has 9 to pick from. How many options are there? Why do we know the order matters on this one? From this information. Because it says what? What in there does it say that indicates that we care about it in order? One's fall and one's spring. So, like, if you switch those around, that's a different order, right? Like, it's different. We have a director here. If Miss Williams chooses to do, a musical in the fall and then play in the spring, that's different than play in the fall, musical in the spring. So it's different when they switch them around. So the order does matter. If you have 9 things and you're trying to pick 2 and you're trying to figure out which one you want fall, which one you want spring, you're putting them in an order, right? Okay? So 9p2, right, is what you can do on your calculator. Or think about this, fall, spring. How many options do you have for fall? 9. Once you pick that one, you only have how many left to pick from? 8. What's 9 times 8? 72. If you do 9p2 on your calculator, you'd also get 72. Okay? Okay, this next one. Okay. I need to just take all of the work off of there because I would rather you guys think about them. So I need to go through all my slides and delete those off. So I'm going to make a note to myself. Delete permutations and combinations off slides. Okay. Here you go. In advertising, because guess what? On your test, when you guys take your test, do you think it's going to say, use a permutation on this problem? No, it's either going to say the order matters or it's going to say something about that you're going to have to figure that out. Okay? So we're in section 4.4. If you get a problem on your test and it's in 4.4 and it's counting the number of ways, you're probably going to use a permutation or a combination, right? But you're going to have to think about which one you're going to use. So why is this one a combination? An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them? Right. How do you know on this one the order doesn't matter? It just says number of ways, and does it say anything about how you're putting them on there, or does it say you're putting them in first, second, third? She's picking 3. We don't know anything else. So unless it doesn't, if it doesn't say really that she's got them in an order, there's no order. So this one would be 10C3. Now be careful. This is calculated totally different. You cannot do 10 times 9 times 8. That was permutation, okay? So since the order doesn't matter, we can't just do that. It actually divides out also the total number of ways because you don't care about the order. So just use your calculator on the combination ones, please, okay? Can't do these ones using mental math. So grab your calculator, do 10C3, make sure that's 120. We sure have gotten a lot of 120s today, but it is? Okay, perfect. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Do we care about what order these people are chosen in? No, it says nothing about putting them in an order. So we have 7 women. How many of those are we choosing? 3. Or and? And we're choosing men. So and means multiply. And we have 5 men, and we're choosing 2. 7C3 times 5C2. That'll give you your answer. Should be 350 possibilities. Okay. Listen up.